Hi, Assalamualaikum. My name is E-Nilam Reader Iot, and today I'm going to do some demonstration for you guys about my project. So, for our devices, this is our devices. We have the buttons, keypad, and RFID reader. Also this LCD. So let's get started. First of all, let's restart this. Where's the button restart? Okay. Can you restart it for me? Yes. So restart. Connect to the Wi-Fi and display. Welcome to E-Nilam. And some instruction to use this keypad. So system is ready. So first of all, in our project we have authentication system where we have to log in first. So let's try an error. What? Incorrect username. That's this is the incorrect one. Oh sorry. It will pop up user not found and please register first. So going to use the valid username, which is Sophia. Set it password and login successful, and it will navigate to the main page. Okay, inside the main page we have the widget that show the state of the LED. If we turn off the light, the LED will start turn on, and it will display on your apps the status of the LED. If we turn on the light again, let's try it again. Okay, turn on. Okay, as you can see, that is one of our devices. So now we're going to test our RFID reader, which we're going to register this book. So let's try it first. So user have to go to book register, and you can click anything because you have to start scanning, and user have to click B to make the RFID ready to read. So scan the book, data fetch. It will display the RFID, the serial number of the book, the ISBN, sorry. So click done, and it will start fetch the data from the database. ISBN is valid. Click OK, and it will enable to user to register the book name and the author name. So as an example, we chose to Bunga Angkasa. Rosa. Start register the book, and registration is successful. Back to the home page, it will display the Bunga Angkasa by Rosa. Okay. Next. Okay, now we're going to try the manual mode for our LED. So this is auto mode. Click this to activate the manual mode. Now it is in manual mode. Right. In manual mode, user can use a keypad to write the ISBN. As example, click A dulu ke? Just click your ISBN. As example, we click 1 2 3 4 5 6 7 8 and press A to send it to the database. So start scanning and click done. It will display the 1 2 3 4 5 6 7 8. Click OK, and you can register like always. Click register and back to the home page. it will display the new book. Where is it? This one. New book. Okay. Now we're going to start a reading session. User just have to choose their books. So we choose Sejati, and then user have to click start and start reading session. After completing this reading session, user have to click stop and click finish. And then user just to click B to ready the RFID. If user not scanning the RFID, it will display a message. You have to scan first, but now try to scan this, and if data fetch, click done. You will back to the home page. Now your book is 22 minutes. Okay. Aku bagi satu je. Every time around you not. Aduh, apa bilang kan?
So this is the code we're going to be using for the Arduino Uno. First we're going to include the wire and liquid crystal I2C libraries, and then we're going to specify the liquid crystal I2C's memory address that's going to be used on the Arduino Uno. In this case it's going to be 0 times 27, and then we're going to specify the amount of columns and rows for the LCD, which is 16 columns and 2 rows. Then we're going to initialize the serial communication at 115,200 baud, initialize the LCD, initialize the backlight of the LCD, and clear any text on the LCD. And then this is within the looping function. We're going to receive data from the serial. Going to receive data via serial communication with the node MCU A, and we're going to display it into the LCD. Once that's done, we're going to reset the receive string so that we don't have repeating characters within the display. This is the code that we're going to be using for node MCU A. First, we're going to include Arduino.h library and do an if statement where if the device defined as ESP8266, we're going to include the ESP8266 Wi-Fi library for Wi-Fi connectivity. Include the keypad library as the keypad is connected to node MCUA. We're going to include Firebase and its dependencies, and then we're going to define the Wi-Fi. As my home's Wi-Fi is called Majestic Masher, we're going to specify Majestic Masher here. During the specification of the Wi-Fi SSID, it is important to not have any quotes or spaces within the name. And then we're going to specify Wi-Fi password, the API key, which is secret. If you are working on Firebase, this API key is something that you should not tell anyone about unless you trust that person, as it could grant them access to your database. Then we're going to have the database URL and the user email and password, which is mandatory. You can create any sort of email you like with the corresponding password. This is necessary as to define this node MCU of what user it is to the database. And then we're going to define the Firebase data as FPDO, Firebase auth, authentication as auth, Firebase config as config, and then unsigned long count equals to 0 for Boolean calculations with Firebase. And then these two right here, these two variables is going to be the amount of rows and columns available on the keypad. Here we're going to map the amount of what kind of letters and characters are on the keypad, and then we're going to specify the pins used on the Node MCU for the corresponding rows and columns. And this is necessary. Then we're going to begin serial communication at 115,200 baud, and then this entire process right here is the connection of the database to the Node MCU and the Wi-Fi to the Node MCU as well. This is the boot screen function, RFID ready print function. We're going to call these two functions whenever we use the keypad. So does the RFID stop print and the constants function. This function is responsible for fetching the data from the database. Now we're going to declare strings of key sequence and the boolean of boot done. So if the boolean boot done is false, then we're going to call for the function of boot screen. It's going to tell you about the instructions, welcome the user into the system, and tell the user that it is ready, that the device is ready. And then we're going to call constants, which is going to fetch the data. Where is constants? This constants. So if boolean from RFID is true and data fetch is false, we're going to print data fetch onto the display and print the RFID data that was fetched from the database. And then there's a bunch of if-else clauses that is used to denote the functions of each characters. For example, we have the asterisk, whose functions is to be used as a backspace, A, to set data into the database, RFID data is used on this page, which is then going to be set to true, and from RFID, which is going to be set to false because this data came from the keypad. And then we're going to print data set on the display and reset the key sequence variable. If no data is inputted, we're going to display onto the display that no data is inputted and not do any operations with Firebase. And then if the key press is B, we're going to set the RFID object in the database to true and then call constants, because this is necessary because the B key is used to enable the RFID reader. Once the user successfully input the data into the database using an RFID card, we're going to instantly call constants to check for the data, because the RFID reader and the keypad is not connected to the same node MCU. We're also going to call RFID ready print to provide feedback to the user that light sensing for the resistors function will be stopped, the RFID will be ready, and C to stop the RFID function. If the key press is C, as you know, we're going to set RFID ready to false, and then we're going to call the RFID stop print function, which is going to provide feedback to the user that the RFID reader is going to be has stopped sensing for an RFID code and readies the light sensor, and that's all. Now the top part of this is going to be the exact same, except for importing the SPI and MFRC522 libraries, and declaring the LDR pin, which stands for a light dependent resistor pin at A0 analog 0, LED pin at digital 0, mode button pin on D1, mode button being the manual and auto switch for the LED, and the light switch pin, which allows for the LED to be turned on and off manually if the mode button is set to manual. We're going to declare manual mode false, LED on false, last light switch state to false, and then this is the declaration of the reset and SDA pin of the RFID reader, which is going to be D3 and D4. Now, and then this part initializes the RFID reader. Set pin mode LED pin to output, LDR pin to input, mode button to input, light switch to input, and begin serial communication at 115,200 baud. And then this right here is going to be the same as before, except for initializing SPI communication and RFID reader. Within this loop, we're going to declare LDR status as the reading from LDR pin, the light dependent resistor. And then in this if clause, we're going to declare we're going to insert the data of RFID ready object from the database into RFID ready boolean to be used locally. So if RFID is not ready, we're going to run this entire class down here, which is if digital read mode button pin equals to low, we're going to set manual mode to its opposite, whether true or false. If it's in manual mode, set the light auto object within the database to false, and then serial print the feedback to the user for debugging. And then in manual mode, we're going to declare boolean of light switch state, where the value of this variable comes from the data read from light switch pin. If light switch state equals to the opposite of last light switch state, and if light switch state equals to high, which means that the light switch is being clicked, which is the light switch being a button is being clicked. And if LED is on, set the LED on to false, and then write to the LED pin low to turn off the LED. And then within this class, we're going to set the state object in the database to false, as it denotes the light state of the light of the LED. As it is off, it's going to be set to false. If else of LED on, we're going to set LED on to true, and then we're going to write to LED pin high to turn the light on. And then we're going to do the exact opposite of this if else clause here. We're going to set light state to true, and we're going to append the value of last light switch state to light switch state. Else, which being if the mode is not manual, being auto, we're going to set the state of light auto to true within the database, and then we're going to run the class below this, and then continue the code below this class, which if it detects the LDR status being the amount of light being read from the photoresistor being less than 200 units, it's going to write to LED pin high, which turns the LED on, and then print the LDR status for debugging, and then set LED on to true, which then after being turned on is going to run a code for Firebase that sets the light state to true, being on. If else of LDR status being less or equal to 200, we're going to write to LED pin low, which turns off the LED, print the LDR status for debugging, and set LED on to false, and set the light state object within the Firebase to false, being light is not on. Now this code down here handles the RFID reader. Now it takes data from the RFID ready object within the database, as the RFID ready is not the RFID scanner is not connected to the same node MCU as the keypad. We have to communicate via the database to turn on the RFID reader. So if RFID ready is true, we're going to run this entire code down here. So as stated here, check if a new RFID card is present. If not, continue to check in loop. If RFID.PICC_read card serial, if a card is detected, it's going to read the serial data, and then it's going to append the characters into the tag variable. Then we're going to print the tag, and then we're going to set the string in RFID data or object of the database to tag, and then we're going to print this for debugging. Then we're going to set its user is on this page to be used by the application to true, and then we're also going to set fetch to display to false. Then we're going to set from RFID object to true. Fetch to display is necessary to be set to false, as it is going to be used by node MCU A it's going to be set by node MCU. It's going to be seen by the node MCU A to detect whether the data has been fetched to the display or not. If it detects that the boolean value of fetch to display equals to false, it's going to run a series of code that fetches the code to the display. And then we're going to reset the tag variable, and then we're going to stop the card communication. Now this is necessary to be done, as from this following function, the RFID scanner's behavior is to search for a card at all times. If we didn't stop it, the else of the every else of the code is going to be bogged down and not be able to run, as this entire RFID scanning program is hogging all the resources. And that's it for the code for .mcub.
So we start connect to the Wi-Fi display. Welcome to E-Nilam, and some instruction to use this keypad.